Hello, lovely students. I'm really excited to do some math with you today. Here is your lesson for the week. All right, so as you can see, we are in 8.4. So that means we are on week 4 for Algebra 2 Accelerated. And for some of you, this is going to be a sad week because it's the last week that you get to do probability. And for some of you, this is a really good week because, probability is over. Oh, that was not my favorite unit. It just depends on what kind of a math student you are. Some people really like probability, some people don't. So let's get started on our last week of probability. And what we're going to be talking about is how many outcomes are possible in different scenarios. So last week when we talked about sample space, we had to list out all the possible ways an event could occur. So it would be like green marble, green blue marble, green yellow marble, green red marble. So we're not going to be making lists like that. We also talked about tree diagrams, right? Where we list all the possible things that could happen by making tree diagrams. And then at the end of every path, we listed all the probabilities. Very related to what we're going to do. However, we're not going to have to draw out tree diagrams. We're going to come up with some strategies so that we don't have to make big pictures. We can just type a couple things into our calculator and be done. All right, so let's talk about the different things we're going to be talking about today. So you can see it says, I can count the total number of possible outcomes. So that's what could possibly happen, right? What are all the things that could possibly happen for an event, or we could say multiple events, using the FCP, Fundamental Counting Principle. We're going to be talking about that. Factorial, that's something else we're going to be talking about. Combination, which is a counting strategy, and permutation, another counting strategy. So by the end of this, you're going to have 4 different counting strategies. And then when you go and do your worksheet or your formative or your summative, the main thing that you need to focus on is, how do I know which counting strategy it's going to be? And then you just put the numbers in the right place and get it done. All right, so before we get started, it's important that we think about some of the information that we're going to need to use in our future questions. So take a minute and you can Google this or however you want to do it, pause the video and come up with how many possible letters are there in the alphabet, right? How many possible single-digit numbers could you possibly write down? And how many possible notes are there in a scale? So go ahead and pause the video, try to figure that out, and then we'll come back and get the answers. All right, so hopefully you are all able to go through and find the answer to those questions, but let's do it together now. So we have, how many possible letters are there? So this question is kind of tricky because yes, in, what we use in school are 26 letters in our alphabet. Lots of different languages and ways of writing have lots of different alphabets. So I'm just thinking about the ones that we use in school for like our English class. 26 total letters, but then if you think about it, you could also have capital or lowercase. So depending on the question, you might have to think about, is it 52 or is it 26? All right, how many possible single-digit numbers are there? Now, a lot of you might be confused by the word digit. Digit just means you only write one thing down. So the number 22 has 2 digits. The number 9 has 1 digit. And this can be kind of confusing because seems like there would be 9, right? Because 1, 2, 3, 4, 5, 6, 7, 8, 9. But actually there's 10 because we count 0 as a possible number as well. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, a total of 10 options if you have to pick a digit. All right, and then how many possible notes are there on a scale? And we're talking about, again, the scale that we learn about maybe in band class. I would consider a couple different answers for this one, and the question would have to be specific. So we could say it's just do, re, mi, fa, sol, la, ti, do, right? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 notes, and then the other notes are sharps or flats, but technically they're different notes. I'm inclined to consider them part of the scale as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 would be my answer for that one. Okay, so this is going to be helpful as we go through, and we're going to be thinking a lot about like how many possible things could you possibly think of. Before we get started, let's review what is the definition of probability? Like, why is counting a number of outcomes related to the study of probability? It's because if you remember from a previous lesson, probability is a number, so either a ratio or a reduced ratio, a decimal, a percent, fraction, that expresses the likelihood of an event. So the probability is the number of ways an event can occur. So that's the key right there. The probability is the number of ways an event can occur. So that's the total possible outcomes divided by the total number of possible outcomes. So it's the outcomes of what we're interested in divided by the outcomes of total things that could possibly happen. So that's why we're studying this, because at the end, you'll see we're going to bring it all together and we're going to use some of these strategies to answer some cool probability questions. Okay, so this first thing we're going to learn about is the fundamental counting principle, but I just call it FCP. All right, fundamental counting principle says that if you have two different categories, right? So the key thing you need to be thinking about for this is categories. So if you have M possible outcomes, and then in the second independent event, you have N possible outcomes, then there are M times N total possible outcomes for the two events together. And this is true for as many events as you can think of. So think about if you're rolling a die and then you're flipping a coin, right? There's six things that could happen with the die, and then 2 things that could happen with the coin. 6 times 2 is 12. So you could have 12 different things that happen. And same thing when we saw 2 dies, right? We saw there's 6 possible outcomes for the first die, and then there's 6 possible outcomes for the second die. 6 times 6, 36. That's how many possible things could happen if you roll 2 die. Right? So it's something that we kind of naturally understand, but there's a word for it, and that is fundamental counting principle, or FCP. So let's take a look at these teacher examples. And just to let you guys know, the teacher examples, I'm going to just keep on going through, and then at the very end, I'm giving you some student examples that are all mixed up, and so we can go through those together, just so you know. I'm not doing teacher, student today. Taking a little different strategy for this one. Okay, so this says you accidentally sleep way past your alarm and decide to just pick out 1 pair of pants, 1 undershirt, and 1 sweatshirt at random. So you're just grabbing stuff randomly. You know you have 3 pairs of pants, 4 undershirts, and 2 sweatshirts. How many different combinations of outfits can you wear? Okay, so what you need to notice about this question to understand that you need to use FCP is that there's categories. There's a certain number of things that are pants, a certain number of things of things that are undershirts. There's a certain number of things that are sweatshirts. So those are different categories of clothing, and you're taking one thing from each category. So in your head, when you see something like that, you're like, ding, 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 FCP. Here's our setup, our strategy to stay organized. We are going to name our categories and list them in the same order that they're written in the question. So it says we have 3 pairs of pants. So pants is our first category, and we have 3 of those. This is just the label, and then I'm writing how many are underneath. It is not a fraction. And then we have undershirts. So that would be 4 total. And then we have sweatshirts. So sweatshirts, I'll do S, and you have 2 options for that. So what you're going to do is you're going to multiply all 3 of these numbers together, just like it says in the definition up here. So 3 times 4 times 2, that's 12 times 2, which is 24. So you would say 24. And then when we use our units for this on your formative and your summative, you don't have to do this, but it's important that you're thinking about this. You'd say there's 24 total outfits you can wear. Or we could say 24 different outfits you could wear it. There's lots of different ways to say the same thing. So let's take a look at this next question. That is also FCP. Okay, it says a standard license plate for a car is given by 3 numbers. So already I know I have categories, right? There's 3 numbers. There's number 1, number 2, number 3. And then followed by 3 letters. So we have our letter, and then another letter, and then another letter. So whenever you see a question about a combination, like a combination lock or a password or a code or an ID number or anything like that, you need to think about it as each digit in that code or password is its own category. So therefore, FCP. Okay, there is no restriction on numbers and letters, except you cannot have the letter F in it. Okay, so we know that when we look at a license plate, it's only capital letters. So that's 26 letters. And then it says you can't use the letter F for whatever reason. So we're going to have only 25 options here. And it doesn't say anything about whether or not you can repeat the letter, right? So I could have MMM as my license plate, that's fine. If it said you can't repeat the letters, then I would have to do 25, and then this next one would be there's only 24 options left, and then this next one would be there's only 23 options left. However, we know that's not the case in our question, and so we're going to leave it as 25, 25, 25, kind of similar to the idea of independent or dependent events, right? Can you have the same one again or not? All right, so now there's no restrictions on the numbers or letters. So we have these numbers. There's 10 possibilities here, 10 here, and 10 here, because you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as options. So I could, in my calculator, do 10 times 10 times 10 times 25 times 25 times 25. Or I could use my noggin and try to be a little bit more efficient. I could say that this is 10 to the, and then change that to the third, and this is times 25 to the, and then change that to the third there. And I get the same answer. So it's up to you how you want to do it. It can be a little more efficient to do it using exponents rather than having just to multiply in a row. So I have 15,625,000 possible license plates. All right, so that's going to be it for the teacher examples and our examples for our first counting principle, FCP. If you want to think about why does this work, I would recommend you try to make a tree diagram for number 1. And these think about it, they're just the same for each one. So if you want to take a minute and just kind of try to think in your head, why does this work? It can be really helpful to draw a tree diagram. Okay, we're going to move on though. We have factorials next. Factorials are a really, really cool counting strategy. And the symbol that we use for factorials is an exclamation point. It's kind of fun. So there's a few different things that we need to know about this. So factorials are used to determine how many different ways people can line it up. It is what's called the product of natural numbers less than or equal to that number. So let's look at a couple examples just using factorial, and then we'll look at the word problems that go along with it. So number number 1 is 5 factorial. If we wanted to do this by hand, we would do 5 times 4 times 3 times 2 times 1. Natural numbers means whole numbers that are greater than 0. Okay, so if I did want to do that by hand, I could. However, there is a button on your calculator, and it's this X with an exclamation point. And so we can use that. So you go to 5, and then you click the button that's above the F1 and below the all clear, factorial like that, and you press equal, and we get 120. So 5 factorial is 120. Again, there's no context with this, so we're not needing to put any units with it. So if you have one of these calculators at home or something similar, you would want to go to the probability menu. And so it's PRB. It's this button right here. It says PRB. And then you would say, go down to the factorial. And actually, you want to make sure you put in the button that you want to do the factorial of. So you go 5 and then press the PRB button and then scroll down to the exclamation point and press enter, and you get 120. If you want to use Desmos, Desmos has this under its functions, so you can find it there. In TI-83 or 8, you would go to your math button and then scroll over to the PRB menu, and it's there. Also, you can just Google the name of your calculator. So TI-30XS multiview would be that. I would type that into Google, and then I'd say factorial, and then there'll be a billion different tutorials for you on how to find that button and use it the best you can. Okay, let's try it with a couple other numbers here. So I want you to get some practice with your calculator, and also you're going to see how amazingly huge factorials get really, really quick. It's kind of like an exponential. So go ahead and whatever calculator you're choosing to use, try 6, 7, and 15 factorial. Pause the video and then come back. All right, so hopefully you had some success using your calculator or Desmos to do that. So these factorials get really, really big, really, really fast because you're multiplying by a bigger and bigger and bigger and bigger number, the bigger the factorial that you're taking is. Now, when I did 15 factorial, I got this really big number in scientific notation. This means this 12 here means that I would have to move the decimal place over 12 times. So I won't give you any of these ones for the formative or summative because it's too hard with the Schoology quizzes. But for this, I would say you would want to write it 1.31 times 10 to the 12th if you were going to round it to the way that I usually would round it. All right, so let's move on and do some of these teacher examples. Yeah. Sorry, I had to pause it for a second. My phone was ringing. Okay, let's get back to it. We're going to do 2 teacher examples of factorials. So the key thing, the key word in any factorial problem is the idea of getting in line. So you have a group of anything, and you're trying to order all of them. Okay, so let's talk about why factorials work in real life. So if we have 8 students that are getting in line for lunch to get a delicious chicken patty, I'm not even sure what that is. If we think about it this way, a line has for 8 people has 8 spots, right? So there's the first in line, there's the second in line, there's the third in line, there's the fourth in line, there's the, fourth, and then fifth, and then I'll use some iPad magic here. and then we have the 6th, and then we have the 7th, and then we have the 8th. So these are all people that are trying to get in line. Now, when you're first lining things up, you have your group of 8 things that you can choose from, 8 people, right? So how many options are there for how many people could be first? Well, there's 8 people that could be first. Well, once you do that, that person is first in line. So you only have 7 people to choose from for second in line, and then 6 for the third in line, and then 5th for fourth, and so on and so forth until you get to the 8th person in line. And that's why factorials work when you have to line things up. It's technically FCP, but streamlined, and you can only use it if you are taking everything in a group, right? If it said you have 8 people, but only 3 of them are going to line up, you can't use it. It has to be 8 people in line, 10 people in line, 5 candy bars that you have to eat. You're going to eat all 5 in order, okay? So line up in order an entire group. That's when you use factorial. So let's get this out of the way here, and we will just do it the easy way. We will just say this is 8 factorial, and then your calculator does it for you. Delete the 5, put an 8 in, and I get there are 40,320 ways that you can line up for lunch. Ways to line up for lunch. All right, so I know that seems like a really, really big number, but we were just talking about how these numbers get really, really big really fast because you're multiplying by a number that's bigger and bigger and bigger and bigger. Or if you're looking at it this way, it would be smaller. Okay, let's take a look at this next question. How many ways can you eat 20 different flavors of Bertie Bott's every flavor jelly bean? Those of you who like Harry Potter know that this is like those jelly beans from Harry Potter where they have like vomit flavor and earwax flavor and lots of weird flavors. So you have 20 different flavors, and you're going to eat them in order. Hopefully you end on a good one, right? You would want to end on vomit or something like that. But you would, how many different orders can you do that? So you have 20 jelly beans, and you are ordering all of them. Now, this is going to be a really big number. Again, on the formatives, I don't have anything this big that you'd need to do, but if I did, you would want to round it to the 100th place and write it in scientific notation like this. And this is ways to eat jelly beans in order. Okay, and so the think about it question, it's just a chance for you to organize your thinking, reword what we talked about up here, where factorial works to line things up because you have 8 options for first place, 7 for second, and so on. So that's why you multiply in order. And the factorial button, all it does is it just does it for you. So you don't have to do 20 times 19 times 18. It just does it for you. Okay. Moving on, take a break if you need to. You can always press pause, get up, stretch, look back at what you did so far, make sure everything's good, take care of yourself, make sure you're focused. Maybe just need a moment to tell yourself, okay, I can do this, refocus. Okay, let's go. So the next counting principle that we're going to talk about is combinations. Now, what we think of as like combination locks, like we would have on our lockers, very different than that. So kind of throw away that definition of the word combinations, and let's talk about this. So we're going to choose a part of a set of items in no particular order. We'll get into what that means, but it's very similar, like we were talking about, to the idea of like before when we were talking about it has to be in a certain order. You're lining them up in a certain order, similar to that idea. So you will use the phrase you'll see this phrase in a lot of questions. Order doesn't matter when you're talking about combinations, okay? On a calculator, it looks different on every calculator, so it's a little bit confusing. But in general, on this calculator, it's going to look like NCR, where N is the bigger number and R is the smaller number. So the idea here is you have a big group, so that's the bigger number, and you're choosing a smaller group out of that bigger group, so that's the smaller number. On your calculator, if you have one of these, you would put in the first number, so let's say we have 20, and then you would press the probability and you'd find NCR, and then let's say the second number was 3, you put that in and you get 1140 for the answer there. Now, if we were to do the same thing on this calculator, we would want to go and see where it says NCR. You would want to press that, and then it doesn't matter which number you put where. So 20 and 3, you get 1140 as well. You can find this button. Oh, it's going to play a little ad for me. You can find this button again on your other calculator if you have a TI-83 or something like that. Underneath, you press the math button, and then you go over to the probability menu, and it's on there. On Desmos, it's under the functions, so you can put it in using Desmos as a function. Okay, so how do we use it? Let's see a couple of examples from me on how to use combinations. Here we go. There are 14 people in Pokemon Club. The first person is Alex, second Brandon, third Pazong, fourth Lily. How many ways can they select a panel of 2 leaders from the group? So what they're saying is we have 4 people, that's our bigger number, and we're choosing 2 people from that group, but it doesn't matter what order we choose them in, right? One person is not more of a leader than the other. It's not like president or vice president or first place or second place. It's just 2 people that are going to equally lead the group, okay? So that's what we're looking for when we're using the letter C and we're using this concept of combinations. We're going to see something different once we get to permutations in just a minute. So on your calculator, you are going to, hopefully this thing is done showing me ads. I'm going to put this in, and then I'm going to put in, oh, got to clear that. So I'm going to do NCR and then 4 and then 2, and I should get 6. So there's 6 different ways that I can choose 2 people to lead Pokemon Club, okay? Let's see if this will, yay. So 6 ways to pick 2 leaders for Pokemon Club. You know how us mathematicians, we're lazy. We don't want to have to write any more than we have to. Okay, so then let's look at this other question here. It says, Ms. Jarmick has 8 different pairs of sweatpants. That's very true right now for quarantine. Sweatpants all day, every day. I'm really enjoying it. I do miss my skirts and my dresses quite a bit, but sweatpants are pretty comfortable. So I'm living a good life right now. And so it says, how many different groups of 5 pairs can she wear in a week? So if I have 8 sweatpants, then I need 5 pairs to wear throughout the week, Monday, Tuesday, Wednesday, Thursday, Friday. So how many different ways can I pick those? It doesn't say anything about how many ways can she put them in order, right? From Monday through Friday. It just says how many ways can you pick the 5 that you're going to wear. So we have 8, and we're going to choose 5 from them. if I go back into there, I can change these numbers. I can also just all clear and retype it. So 556. So there are 56 groups of 5 sweatpants. Okay. Let's take a look at the next concept. The next concept is very, very similar, but it is related to the idea that order does matter. So this word is permutations. And so you're ordering a chosen set of items. So you will use the phrase, you guessed it, order matters. And on a calculator, it looks like NPR. Again, the N is the bigger group, and the R is the smaller group. So let's look at these examples. I kind of designed them to be good for being able to tell the difference between what we just did and this new concept of permutations. So here it says there are 4 people in Pokemon Club, same question, but it says how can they select a president and a vice president? So it matters what order you pick them in, because if you pick Lily and Fazong to be the leaders, it would be different whether you made Lily president or Fazong president, right? And so on your calculator, you are gonna do 4P2, and it's in all the same spots we just talked about on Desmos, on your physical calculator. If you're using this calculator on your iPad, then you would do the NPR button. And then 4 and 2, and we are done. So this is 12 ways to pick president and vice president. Okay, so let's go and look at number 8. So Miss Jarmick has 8 different sweatpants. Again, living my best sweatpants life right here. And how many different ways can she wear them Monday through Friday? So this one does mean we want to put them in order in how I'm going to wear them. So it would be different if I wore my pink sweatpants on Monday, my green sweatpants on Tuesday. That's different than if I did my green on Monday and my pink on Tuesday. So let's same idea, right? Let's put in our calculator. We have 8 total that we're choosing from, and then we're putting in order 5 of them. So let's go back in here, and we have 8 sweatpants, and we are putting them in order in how I'm gonna wear them throughout the week. All right, so I have 6,720 different ways to wear sweatpants in order Monday through Friday. Notice how I'm getting lazy with what I write. Okay, so this think about it question is pretty important to understand deeply what's going on. So why is it, these are the same exact questions, why is it that that combination, same numbers, this has half as many outcomes as this one? Again, this one has 56 outcomes. This one has way more outcomes than that. So how come? Why? I want you to think about it. Press pause and try to think about why does one counting strategy have more outcomes than the other? Right, so hopefully you're able to think about that. We're gonna keep on pushing through. There are, let's see, 6 different student examples. I am gonna go through each one, not entirely, but I'm gonna go through some key differences in each one. But what I'd like you to do is press pause and go through before we even start going through them. And I just want you to name what counting strategy you would use to solve them. So you're either going to write FCP, hopefully not in highlighter. You're going to write FCP, Fundamental Counting Principle. That's the first one that we learned about with categories. Or you are going to write factorial, right? That's the idea that you have a group of things and you're lining them all up. Or you're going to say combination, so NCR. NCR is you're taking a smaller group from a larger group, but it doesn't matter what order you're taking it in. And then finally, you're going to say whether it is NPR. So is it you're taking a smaller group from a bigger group, and it does matter what order they are lining up in or what order you take them in, or maybe they have a different title like president or vice president rather than just being equal leaders together. Okay, so pause and then check it back at what counting principle you're going to use for each question. Okay, so hopefully you were successful and you found that you have NPR for the first one. That is because we are naming the group that we're choosing. So we are naming president, vice president, and secretary. Assuming that you can get them to stand in line, how many ways can you get 5 kindergartners to line up for snacks? I'm sure a lot of you are helping your younger siblings with this distance learning, so you know what I mean when can you even get 5 kindergartners to line up? So that one is a factorial because you're lining up all of your group. The entire group is being lined up. All right, so this one has to do with a password. So automatically you should think FCP, and if you look a little more carefully, you can see that the first 3 are letters, the last 2 are numbers, and so you have 3 letter categories and 2 number categories. The next one says you have kittens that need to be adopted. You have 11 kittens, 3 of them you're gonna pick. It doesn't say anything about put them in order of your favorite or how many different ways could you name them, these 3 names or whatever it might be. So that one is NCR because you're just taking 3 kittens home. It doesn't matter what order. This one says when you are opening a combination lock. Now that's meant to trick you because it is not a combination. It is FCP, even though we call it an combination lock. Actually, it has 3 different numbers. So how many different combinations are there for this lock? It's actually category. Anytime you see a password, combination, something like that, then you know that you need to use FCP because there's categories. Each part of the password is its own category. All right. And then this one says the math team has 8 members. 4 of them are going to participate. It doesn't say anything about being like a captain or a co-captain or secretary or note taker or anything like that. So it's just everyone's kind of equal. So order does not matter. Okay, so now you know what strategy you're going to use. I'd like you to go through and I'd like you to please try and solve them. So go ahead and pause and then come back and we'll go over the answers. All right, so hopefully you had some success with these. Let's take a look at what the answers should have been. The first one, 15, choose 3. Make sure you set that up correctly. I feel like the fact number 10 was pretty straightforward. Number 11, maybe not quite as straightforward. Remember, if you have capital or lowercase, then it's 52. But if it's just lowercase or just capital, then it's 26. And then there are 10 digits. So I just multiplied all those together. The next one is the kittens. So that should be pretty straightforward. Just make sure you know how to use your calculator, whatever calculator you're choosing to use. FCP, this one, 40 options for the first one. And then since you can't repeat the same number, it'd be 39 for the second one and then 38 for the third, even though your combination lock's at in the school, you can repeat the number. This one, for whatever reason, they wanted you to think about that. Something kind of interesting that happens with permutation, factorial, and FCP is that sometimes you can get the right answer by doing it a different way. So notice that if I were to do this and I were to say, I want to do instead, I have 40 and I need to choose 3 in a certain order, then I'm going to get the same answer. So that's kind of interesting, something that you can think of. You need to pick 3 numbers for the combination, and the order matters. So you could use either method. I always use FCP when I'm dealing with passwords just because it helps me stay organized. But just notice that. Oh, and one other thing too, if you think about factorials, they're about lining up. And so are permutations, right? Permutations are also about lining things up. So if I have a group of 5 and then I have to line up all 5 of those, I'm going to get the same thing as if I did 5 factorial, because they're both asking the same question. So yeah, something to keep in mind. If what I just said was confusing, then don't worry about it. You can ignore it. But here we go. We're going to go on to this last one and talk about it. NCR, just make sure you're using your calculator and reading the question really carefully. So one thing that I just wanted to say here is that, if you went to the Humane Society and you were going to try to pick 3 kittens out of a litter of 11 kittens, you probably wouldn't be that overwhelmed, right? You would just be like, oh, I like that one, I like that one, I like that one, those are my 3, and I'm done. But the reason why our human brains have such a hard time with this is because we simplify our problems down, when actually there's 165 ways that you could possibly choose those 3 kittens. And if you were to think about every single one of those possible combinations, it'd make you go crazy, right? So just think about this. Sometimes these numbers seem too big to make sense, and it's because our brains were in real life making these kinds of decisions or try to figure out who would be the best president, vice president. We tend to make things a little bit smaller so that we can handle the questions. All right, so that's going to be it for our lesson today. I know that the notes sheet has another page, but I decided, you know what, let's keep things simple this week, and hopefully you guys are feeling pretty confident about the materials this week, and hopefully you'll have a little extra time to catch up on last week's material. I know last week's material was pretty challenging, so take some time and go back, and you can always try to improve your score if you have submissions left for your summative or your formative, and give it your best effort. Always reach out to me if you have questions. I will post a challenge video from Khan Academy this week. It's kind of a cool way to make a connection between what we learned about this week, which was the counting principles, and what we did in polynomials when we were doing binomial expansion. I know some of you really liked binomial expansion, and there's actually a really, really cool connection between combinations, permutations, and the binomial expansion. So try the challenge if you have some extra time or if you're interested. Otherwise, keep up the great communication. I'll see you on office hours Tuesday or Thursday from 1:30 p.m. From 12:30 p.m. to 1:30 p.m. Remember, the Google Meet code is JARMIC Accelerated, Algebra 2 Accelerated. So capitalization doesn't matter. It's JARMIC, Algebra, the number 2 Accelerated. And I'll see you there. Have a good week.